Hi guys, so today we're going to learn chapter 4, still chapter 4, and today we're going to focus on 4.2 stoichiometry, and you should be able to perform some calculations regarding masses and moles and also volumes and concentration. So what is stoichiometry? It is a quantitative study of reactants and products in a chemical reaction, and we can use it to calculate the quantity of species during a reaction. Quantity here referred to mass, moles, volume, and even concentration. In a short form, I call it a mole comparison, and it is only applicable if the equation is balanced first. So the first example shows 1 mole of CaCO3 reacts with 2 moles of HCl to produce 1 mole of CaCl2, 1 mole of CO2, and 1 mole of H2O. And that's how you read the equation. Now let's have a look at the second example. How many moles of hydrochloric acid, HCl, do we need to react with 0.5 mole of zinc? So first thing, make sure the equation is balanced. So if it's already balanced, now from balanced equation, 1 mole of zinc reacts with 2 moles of HCl. Okay, so if I have 0.5 mole of zinc, okay, so we can compare with the mole of HCl here, so we don't have it yet, so we just put X mole of HCl. And then what we do next is we do cross multiplication to get the value that we wanted. So X equals to 2 times 0.5 equals to 1.0 mole of HCl. So that's how much mole that we need for this equation. So example 3. How many moles of H2O will be formed when 0.25 moles of C2H5OH burns in oxygen? So now we're interested in H2O, the products, and also C2H5OH, the reactants. Now, keluarkan air keramat kita. From balance equation, 1 mole of C2H5OH, 1 mole di sana, will produce, okay, guna balik simbol tadi 3 itu, 3 moles of H2O. Okay, so we have 0.25 moles of C2H5OH. We put it there. Okay, and this one we're gonna find. So we put X mole of H2O. And the next cross multiplication again. So X equals to 3 times 0.25. So X equals to 0.75 moles of H2O. Now example 4a. 3HCl plus AlOH3 produce 3H2O and AlCl3. So we are given with balanced equation here. So the question is, how many grams of aluminum hydroxide will react with 5.3 moles of HCl? So let's highlight the species that we're interested in, HCl and AlOH3. And then we put out our ayat keramat. From balanced equation, 3 moles of HCl reacts with 1 mole of AlOH3. Right? So we are given with 5.3 moles of HCl, so that will react with X mole of AlOH3, and the next cross multiplication, so 3X equals to 5.3. Okay, so X equals to 5.3 divided by 3, then you should get 1.7667 mole of AlOH3. But we are not asking for moles, they're asking for grams. So we have to find the mass of AlOH3. So mole to mass is times by molar mass. Alright. So therefore mass of AlOH3 is equals to 1.7667 moles times with 27 plus 3 times 16 plus 1, which is equals to, let the calculator do the job, you should get 137.8 grams of AlOH3. Now example 4b. What quantity of HCl in grams that can be consumed by 0.750 grams of aluminum hydroxide? So they're given with mass and they ask to find mass. So first, if we are given with mass, we have to find the moles first. So mole of AlOH3 is equals to mass over molar mass, 0.750 divided by 27 plus 3 times 16 plus 1, and you should get 0.009615 mole. Next, kita keluarkan air keramat kita. From balance equation, so 3 moles of HCl reacts with 1 mole of AlOH3, So we have calculated the mole of AlOH3. So replace there 0.009615 mole AlOH3. Meanwhile, HCl we want to calculate now, so we put X there. So cross multiplication. So X equals to 0.009615 times 3. So you should get X equals to 0.028846 mole of HCl. But we haven't finished because the question is asking for grams, so which is mass. So mole convert to mass with times with molar mass again. So mass of HCl reacted is equals to 0.028846 mole times with the molar mass of HCl is 1 plus 35.5, and you should get 1.0529 grams. So, example 4C. If 9.5 grams of AlOH3 were reacted in the reaction, determine the mass of water produced. So, kita interested dengan AlOH3 dan juga water. So, we are given with the mass of AlOH3, so we have to find mole first. So, mole equals to 9.5 divided by the molar mass of AlOH3, and you should get 0.1218 mole of AlOH3. And then macam biasa, keluarkan ayat keramat kita. From balance equation, 1 mole of AlOH3 produce 3 mole of H2O. So that symbol, let me just emphasize, yang tengah-tengah tu 3 garis tu can either means reacts with ataupun produce something. Okay, so kita continue 3 garis lah. So kita continue. So mole of AlOH3 is already calculated. So 0.1218 mole of AlOH3, okay, will produce X mole of H2O. Kita mau cari X itu apa? So cross multiplication, X equals to 3 times 0.1218 moles. So you should get 0.3654 moles of H2O. Therefore, mass of water produced is equals to moles times molar mass. So 0.3654 times with the molar mass of water, 2 times 1 plus 16, you should get 6.577 grams of water. Now let's have a look at example 5. Hydrogen peroxide H2O2 decomposes to produce water and oxygen as in the following equation. What would be the volume of O2 released from the decomposition of 250 ml of 2 molar H2O2 at STP? So this equation is already balanced. So we are interested in the volume of oxygen and also H2O2. So we are given with the volume of H2O2 and the molarity of H2O2. Alright, so first using that information, you can find the mole of H2O2 decomposed, which is M times V. So remember the formula, mole equals to MV? Yes. So molarity is 2 molar times with the volume is in milliliter somehow, but the volume must be in liter to use this formula. So we have to divide by 1000 and you should get 0.25 liter. Then baru masukkan dalam formula and then you should get 0.50 moles of H2O2. Then macam biasa, keluarkan ayat keramat kita. From balance equation, 2 moles of H2O2 produce 1 mole of O2. So we have 0.50 mole of H2O2, X mole of O2, cross multiplication, 2X equals to 0.50 moles times 1. So X equals to 0.25 moles of O2. But the question is asking for volume of O2 at STP. So what you have to do, the volume of O2 at STP would be equals to, first remember moles to volume, you have to times with molar volume at STP. So 0.25 moles times with 22.4 dm cube per mole. So you can cancel out the mole unit there and you should get the answer 5.6 dm cube or 5.6 liter. Let's have a look at example 6. So 16.50 ml of 0.1327 molar KMnO4 solution is needed to oxidize 20 ml of FeSO4 solution in acidic medium. So confirm this is redox reaction. What is the concentration of FeSO4 solution? The net ionic equation is given down there. So net ionic equation bermaksud equation ini sudah balanced. So all you have to do is just use it. So we are interested in the concentration of FeSO4. Jadi, di mana FeSO4 di dalam equation tu? Kalau kamu nampak tiada kan? Jadi, kita ada Fe2 plus dan ada MnO4 minus saja. So actually, this two solution has been represented by the respective ions in the equation. MnO4 minus represent KMnO4 solution, while Fe2 plus represent FeSO4 solution. And in this case, SO4 and K does not involve in the equation. It is just what we call as spectator ion. They're not involved in the redox reaction. Dia datang tengok-tengok saja. So this is the balance equation and we are given with all this information in the questions. So method 1, okay, there are two methods to solve this question. So method 1, first we find the mole of MnO4 minus, so M times V, and the volume here need to be converted into liters, so divide by 1000. Okay, so kadang-kadang di sekolah dulu kita panggil dia MV per 1000. So the final answer here should be 0.00219 moles of MnO4 minus. So from balance equation, 5 moles of Fe2 plus reacts with 1 mole of MnO4 minus. So kita sudah ada mole of MnO4 minus, so 0.00219 mole MnO4 minus, X mole Fe2 plus, cross multiply, so X equals to 5 times 00219 and you get 0.01095 moles of Fe2 plus. Okay, soalan suruh cari molarity. So mole of Fe2 plus equals to mV. So M kita mau cari. V is 20.0 ml, so divide by 1000 again, so MV per 1000, sebab kita mau volume tu dalam liter. Kalau dia mau pakai formula MV, mesti dalam liter. So kita tukar-tukar tempat, ganti masuk, so you should get 0.5474 molar of FeSO4 solution. So the second method is called mole ratio. This is a shortcut. Macam mana kita mau pakai ni bila kita ada dua set molarity dengan volume, M dengan V. Ada dua solution yang react. Jadi, kita punya formula yang kita boleh pakai adalah MAVA over MBVB equals to A over B. Jadi, kita kena labelkan spesies yang pertama sebagai A, yang kedua sebagai B. Walaupun dia bukan acid ataupun base. Kita label saja dan kita boleh pakai formula ini. So, jadi automatic VA ada, MA ada, VB ada, MB ada di sana. Jadi, yang kita mau cari sekarang adalah MA. Yang lain kita boleh ganti masuk dalam equation. So, 20 ml VA and then 0.1327 MB. Okay, VB 16.5 ml. And kalau kamu perasan, unit kita tidak payah tukar pergi liter. Sebab kalau kita tukar pun dia akan cancel out juga nanti. So no need to convert into liter. Jimat kita punya masa. And A dengan B kita dapat daripada coefficient dalam soalan tu, dalam equation. So 5 and then 1. Jadi tekan-tekan calculator, you should get the final answer 0.5474 molar juga. So the molarity of FeSO4 solution is equals to 0.5474 M besar. Now, test yourself with these two questions with the given answers. And don't forget to like, share and subscribe. Thank you.